sometimes you have a bunch of sets and you know how many elements are in set A and set B and the intersection. And you want to find out all of the other regions. You want to draw the Venn diagram to get an understanding of how many are in each region. An example of that is a question like this. We know that the number of elements in set A, that's what this means, is 5. So A has 5 things in it. B has 10 things in it. The intersection has 2 things in it, and the universe, all of the things together, are 30 things. The size of the universe set is 30. So it's hard to understand from that what it looks like and how many is in the complement and all that sort of thing. So normally the first thing you'll want to do is to create a Venn diagram to show the information. I would recommend, we've got 2 sets here, basically A and B. So we'll make a circle for A and a circle for B. We'll make them overlap because there might be an overlapping region. We'll label them A, B, and the universe. And to start putting numbers in, it's tempting to start, for example, with this. Number of elements in A is 5. And it's tempting to say, oh, okay, well, there's 5 in this region here. But this region is just this moon-shaped region. And there might not be 5 elements in there. You know, maybe there are 4 elements in here and 1 element in here. That way, inside A, there are still 5 elements inside A. So it's a bit confusing to start with that. There's not enough information if we just look at that. So let's instead start with the intersection, the number of elements that are in both sets. The number of elements that are in A and also in B, so they're in that overlapping region, is 2. So the number here is 2. See, I start with this one because this fact here corresponds to exactly this region here. There are 2 elements in the intersection of both sets. Now we can look at another fact. We can look at the fact that the number of elements in A is 5. So A is this whole circle, and there are 2 elements in here and 5 elements in the whole circle. So how many are in this part here? 5 take 2 is 3. Just to check, how many elements are in A now? 1, 2, 3, 4, 5. There are 5 elements in A. You might also notice that I'm putting the 3 in brackets. That's to show that there are 3 elements in that region. Because otherwise I might be saying, oh, this contains 3 numbers, right? So to show that there are 3 elements in here, we don't know what they are, but there are 3 elements in there. I write a 3 in brackets. 3 elements in here, 2 elements in here. We can use similar thinking to get the number of elements in B. So we know the number of elements in B altogether is 10. So this yellow circle, there are 10 elements in that yellow circle. Out of those 10 elements, 2 of them are in the middle. So how many elements are in this moon shape? 10 take 2 is 8. Just to check, inside this B circle, I've got 2 elements here, 8 elements there, 10 elements in that circle. So that checks out, that works. Finally, the number of elements in the universe is 30. So, we want to figure out how many are in the outside. They're not in A and they're also not in B. Well, we know that there are 30 in the whole thing. There are 30 elements in the whole universe, minus 3, minus 2, minus 8. Another way of thinking of it is that in this region, there are 3 plus 2 plus 8. 3 plus 2 plus 8 is 13. There are 13 elements in here. So outside, the elements that aren't in anything is 30 take 13. So I'll write here, maybe up here, 30 take 13. Ooh, That's a funny 3. 30 take 13 equals 17. So, in here, there are 17 elements that aren't in A and they're also not in B. They're not in any of those. All right. Now we can answer questions, now that we've visualized what these two sets look like and how much they overlap. For example, how many elements are in this set, A union B? A union B is this whole region, the elements that are either in A or in B or in both. There are 3 elements here, just in A, plus 2 elements in both, plus 8 elements in B. So in total, we have 13 elements in A union B. How many elements are in A but not in B? Well, that region is this here. I've written this in a bit of a funny way, haven't I? I've said the number of elements in A and not in B. This symbol, the apostrophe, means the complement or not A. The complement or not B. Everything not in B. So this means A and also not in B. So, the hard part there is the notation. The easy part is the answer, the question. A but not in B. That's this section here. There are 3 elements that are in A but not in B. So, to summarize, my tips here are to start with the intersection. So that is the elements that are in both sets. So it's easier to start with this fact than the other ones. N of A, N bracket A bracket, means the number of elements in set A. And we write bracket 3 bracket like this to show that there are 3 elements in that region, even when we might not know what those elements are. Maybe they're A, B, and C, or 7, 9, 10. The important thing is that there are 3 in that region. I hope this has been helpful, and remember to ask me lots of questions. Get lots of practice, check your answers, ask me questions. That's how you grow.